So this is going to be a very short video on how to read phase change graphs. Okay. All right, so a phase change graph shows a change in states as the temperature changes within a substance. So it's going to show how a substance changes from a solid into a liquid, from a liquid into a gas. All right, now when heat is added to ice, right, the water molecules begin vibrating faster and the temperature increases. Right, and when the temperature reaches the melting point of the water, the hydrogen bonds begin to break. Right, and as the hydrogen bonds break, the ice melts into a liquid. Right, so here, remember, we see this how the water molecules arrange themselves within a solid, and then as you add energy, thermal energy to it, these bonds begin to break, and the water molecules are able to slide past each other so that water is able to flow. All right, now freezing is just the opposite. When heat is removed from a liquid, the molecules begin vibrating slower and the temperature decreases. Right, and so then when the temperature reaches the freezing point of water, the hydrogen bonds begin to form. All right, so here we go from water molecules being able to flow past each other to where they're rigidly structured, aligned into a crystal structure to form ice crystals. All right, and so the liquid is freezing into a solid. Okay, so this is, a phase change table or phase change graph. Right, and it's showing you solid and liquids, and then here's the melting and freezing point. Right, so heat is on our x-axis and temperature's on our y-axis. Right, and so as we increase the heat energy, the temperature increases. And so you're seeing, a slanted line where the temperature is increasing as you add heat. There's a direct relationship. Add heat, temperature increases. Remove heat, and temperature decreases. Right? Okay. Now, so everywhere you see where it's increasing or decreasing, where it's slanted, that's where the temperature is increasing or decreasing. All right, now at the melting and the freezing point, the the thermal energy, isn't being used to raise the temperatures at that point. Instead, at the melting and freezing point, the energy is being used to form the bonds between the molecules. And so right at the melting and freezing point, temperature is not increasing. And so on a graph, it flattens out there because there isn't an increase or a decrease in temperature right at that melting and freezing point. And so for any substance, when you see a phase change graph for that substance, you can tell where the melting and freezing point is, what temperature it will be at, by looking at where the graph flattens out. Right, now the same thing occurs at the boiling and condensation point. Right at that point, right at that temperature, the energy is not being used to raise the temperature of the liquid, and the energy is also not being used to raise the temperature of the gas or to decrease the temperature of the gas or the liquid. Instead, it's being used to break the bonds so that the substance can change from a liquid into a gas. And so again, you can tell the boiling point if you look at a phase change graph for any substance, where it flattens out at the higher temperature than down here at the melting and freezing point. The one that's where it flattens out the second time at the higher temperature, that's going to be the boiling or condensation point. Okay, so it's real easy to see, to read these graphs, if you remember that. All right, so you can look at any phase change graph. You should be able to determine the melting and boiling point, as well as the state of matter that the substance will be in at any given temperature. All right, so here we have a phase change graph with a freezing and melting point at 0 degrees, and a boiling and condensation point at 100 degrees, which should tell you that this is liquid water since that's the freezing and or the melting and boiling point of water. Okay, now when you're answering questions about this, you can make it easier on yourself by just labeling these points. So the bottom, the place where it flattens out at the cooler temperature will be the melting point. So just put an MP there. Okay, now before something melts, when it's colder than melting, it's going to be a solid. So put an S there. All right, between the melting point and the boiling point is where it's going to flatten out at the higher temperature. Put a BP for boiling point and put an L between the two. Okay, and then put a G above it. All right, and this will make it really easy to answer these questions. So here's an example question. So at 50 degrees Celsius, is this substance a solid, liquid, or gas? All right. So it's going to fall right there. So again, you can make it easy on yourself. Just label your points, and 50 degrees falls right between the boiling point and the melting point. So it's going to be a liquid. It's as simple as that. All right. Hope this helps.